Welcome to Cloud on Air, live webinars from Google Cloud. And this is CETV. We're hosting webinars every Tuesday. My name is Yuri Grinshteyn. I'm a cloud customer engineer here at Google. And today I'm joined by Spoons, the CTO and co-founder of LightStep, to talk about observability in distributed applications. You can ask questions anytime on the platform, and we have folks on standby ready to answer them. So let's get started. So first of all, Spoons, thank you so much for being here today.
Yeah,
really appreciate it.
My pleasure. It's great to be here.
All right. So let's talk about microservices.
Sure.
I think a lot of folks think of them as kind of the ultimate answer to all of their problems. What do you think?
Yeah, there's a lot of great things about microservices, serverless, other sort of modern architectures. I think it lets you scale, lets you divide the work among your team in a lot of ways. So yeah, it's great.
Yeah, but I'm assuming that we wouldn't be here today if they were perfect.
That's right. I think as much as that microservices help you move quickly, you kind of often lose the big picture for what's actually happening in your application.
Yeah, and I think one of the ways you lose is sort of one of the issues you have is around observability, right? And the more services you have, the more stuff you have talking to each other, the harder it is to understand what's going on.
Yeah, especially if you kind of step back and think of it from your user's point of view. Users don't care how many microservices are involved. They just care about the experience they have. And that's going to cut across all of your services in a way that maybe your traditional tools are not taking account.
Yeah. So what are some of the observability challenges that you've seen with microservices architectures?
Yeah, I mean, I think it really starts from just the tools themselves. So I think, when you think about what's happening, we saw this tweet that I think is pretty funny. I replaced our monolith with microservices, and that turns every outage into a murder mystery. That's really kind of coming from the fact that people kind of look at these three tools in terms of three sets of tools and how they look at observability. Metrics, logging, and tracing. Sort of three approaches to how you might see what's going on inside the application itself.
So let's talk about those three. So first, metrics, right? They're time series data. What are they useful for? What do they tell us about what's happening within our application?
Yeah, metrics are great for understanding when something has gone wrong. It's great. It's easy to set thresholds, alerts, things like that. You can get notified. They're not so great about understanding why something's gone wrong. So it's easy to tell that there might be correlated failures, but understanding the causes of failures can be pretty hard.
Sure. All right. So yeah, I think that's a good way of describing it, right? Metrics tell us when something happens.
Yeah.
So how do we find out what is happening?
Yeah. So again, traditionally, maybe you look at a logging tool to do something like that. Logging is great about giving a ton of detail about a specific transaction or maybe within a specific service. And yeah, it can give you that detail. I think the downside of it is really the volume of data that you might have there.
Sure. All right. So we've got metrics, we've got logs. What about traces?
Traces are good. It's sort of the new kid on the block, I feel like, in this. In some ways, one of my co-founders built a system at Google called Dapper, which was Google's distributed tracing system. And Dapper was great for understanding the latency and some of the other issues that were coming up in Google's web search, and able to really identify for a particular search, where was the latency, where was the slowness coming from? You do a search as a user, you don't think about it, but there's web docs, there's news, there's personal results, there's images, there's all kinds of things that are sort of feeding into that. Any one of those things could be a problem at any time.
Sure. All right. So we've got our metrics that tell us kind of what is going on and when. We've got logs that allow us to understand errors and specific events. We've got traces that tell us what our latency is. And then we have distributed tracing, which kind of tells us what's latency between different microservices.
Yep.
All right, so why is observability still a problem?
Yeah, so each of these things has kind of their own problems in a way. Really to take advantage of metrics, you want to be able to dig in a bit and understand, is this problem only occurring in the latest release? Is it occurred in all releases? Okay, well, how do I do that, right? I tag it, right? I put a tag on the data, so now I can sort of segment by different releases. Probably also want to segment maybe by host or data center, so I can figure out if there's some sort of infrastructure problem.
Sure.
A lot of folks, us included, will tag based upon customer IDs. But these things start adding up. Yeah, exactly. And when you think about the way that a metrics tool is built, really it has to keep track of every one of these individual streams and really the kind of full cross product of all those things, every different combination. And this is what folks kind of refer to as sort of the cardinality problem in a sense.
Sure. All right. So metrics are good because they tell us when things are happening, but it's hard to keep track of them, especially when you got a big system, lots of services, lots of customers, lots of metrics. All right. Well, surely logs don't have any problems.
Yeah. They might have a few. So logs are great, but you really end up paying by volume a lot of the time.
Yeah.
And if the amount of logging that you're generating is just proportional to the amount of service that you're providing, cool. That's just like fixed cost. It's no problem. You can think about that. But as the complexity of your service grows and you start building out sort of a microservices or a similar architecture, you're going to want to add more logging for each new microservice that you add.
Yeah.
So now the amount of logging that you're generating is not just proportional to the traffic that you're serving to your users, but also to the complexity of what you're building. And that means either your costs are going to go way up, or if you fix your costs, you're going to have to reduce the amount of logging that you do.
So you have to do things like sampling.
Yeah, or even just, I know folks won't log in some environments, like they just don't log in their staging environment because it's too expensive. That's unfortunate because that could be really valuable in diagnosing problems in that environment.
It's hard to reproduce problem outside of production if you don't have logging turned on in those environments.
Yeah, exactly. So,
all right. So logs don't necessarily scale as well. All right. Let's talk about traces. What are the issues there?
Yeah. So at least in the way traces were built at in Google and in the way that they were built in Dapper is they were actually looking at a pretty narrow problem, which is looking at, for web search, how do we understand overall latency?
Sure.
And it turns out that Google does like a bazillion requests every second. And so you can actually throw away a lot of the data and still get a pretty good signal. And so for Dapper, actually, the costs were not in terms of the overhead in the application itself. So that is like in web search, Google's still, I think anyway, basically doing instrumentation on every request that comes in. The thing that turns out to be expensive is actually just storing all of that data.
That makes sense. I can see how that could be a lot of data.
Yeah, so within Dapper, kind of the default mode anyway is that you throw out 99.9% of the data almost immediately, and then you throw out another 90%, so you're down to 99.99% of the data is thrown out. So there's a tiny fraction with left. And again, like 0.01% of a bazillion is still like still a big number.
Yeah.
But now you start to miss out on some of the finer detail where it's like, okay, well, if you're just looking in aggregate across all of Google's web requests, great. But if we want to start talking about maybe a different use case where you've got these interesting segments of different customers, you're interested in sort of a small fraction of your customers, the chances of that small fraction overlapping with this 0.01% are starting to get small.
Yeah, so I can see some of the challenges that we're starting to identify, right? It's hard to keep track of lots of different metrics. It's hard to keep all the logs just because of the amount of data we have to store and how much it costs. Whether you're paying your infrastructure cost to yourself on your data center or to someone like Google to store them, it's still a lot. And then traces also create a lot of data. Is that right?
Yeah, so I think you actually hit it right there. I mean, the way that we kind of think about these at LightStep is that metrics, logs, and traces are just data. And as much as like people kind of in the past have thought about it as three separate tools that you've got in your tool belt, there's a lot of opportunities to really look at where you can use them to interact and leverage aspects of metrics and how you do log collection, look at how log collection or how logs can be combined with traces. And that way you can sort of look more holistically at like what are the problems that we're actually trying to solve as an observability tool.
Yeah. So now I feel like I'm at that person in the infomercial who's like struggling. I'm like dropping things, or I'm trying to chop vegetables, and I don't know what I'm doing. And then the announcer comes on and says, surely there must be a better way.
There's a knife for that, right?
All right, so tell me about the better way.
Sure, so let's just do kind of a quick demo. So this is sort of one view into what we can show in LightStep. So this is kind of a demo app that we've put together. So what we're doing is we're monitoring an application here, which does some sort of reservation system. I don't know if it's cars or seats or tickets or something like that. But anyway, there's an app, there's a bunch of microservices on the back end. And what we can do is we can look at it across a bunch of different dimensions. So here we're looking at a particular set of requests that are coming from the iOS app.
Okay, things look pretty flat, right? Everything seems to be consistent and fine here.
Yeah, so sort of kind of three parts of what we're doing. On the top, looking at latency, which is sort of the slowness, how long it's taking to respond to requests. Below that, the rate of requests, and then below that, the error rate. And so rate's pretty steady, no errors are happening, so that's all good.
Yeah.
And looking at latency, yeah, it's pretty flat. What we're doing here is we're only showing, though, the median latency.
Okay.
So that's basically, sort of 50th percentile on what we're doing. If we sort of step back a little bit, we can actually, in LightStep, look not just at the 50th percentile, but look at these higher percentiles above that. So we can look at 95th percentile, 99th percentile, or even 99.9th percentile. When we look at those, actually, there's a lot more story to tell about what's going on here.
Yeah, so this is actually showing you a very different picture, right? Even though our median latency is very flat and there's really nothing happening there, when we start going to the high percentiles, it really looks like there was an event here. There was a latency spike, then latency sort of almost crashed, and then it evened out back to kind of its expected value.
Yeah.
So that's a very different picture that you get when you look at those higher percentiles than what you get when you're just looking at the median.
Yeah, and that's, I think, super important, especially in a distributed system. One of the reasons is that these high percentile latencies are often sort of bellwethers for what's going to happen for most of your users later on. So these are really users that are kind of pushing the envelope in a way. And as your overall traffic grows, hopefully, it's not just going to be 1% of users that are experiencing that, it's going to be more. But if you can get ahead of it and fix it for those 1% before it becomes a wider spread problem, that's great. The second thing is when you're building a distributed system, we're really just looking at one component here, and we're looking and seeing that 1% of the requests to that particular component are slow. But if you think about it from a user's perspective, their request is going to hit a whole bunch of different services. So if each of those has 1% that's slow, the chances that a user is actually having a bad experience are going to go up and up and up. So maybe in an individual service, it's only 1% of requests, but if there's 20 services, it's going to be 20% of requests that are going to be slow for the user.
All right, so next obvious question. I know that we're having some latency issues. Why? What's going on?
Yeah, so I think, this, I kind of think of latency, the latency measurements that LightStep does is kind of table stakes in a way, like you just got to do this. I think one of the cool things that LightStep adds on top is that we're actually also keeping a record of transactions across these different latencies and actually using the latency as a kind of signal to tell what might be an interesting transaction to go look at. So each of these little dots here represents some transaction where we've captured a complete trace for that.
Okay, that's a lot of traces.
Yeah, I mean, we pick what we think is a kind of representative sample. We don't expect a human to look at all of these. The way that I kind of think of it is like sort of automated crime scene investigation. So you're the detective. You know that something's gone wrong. You've got this robot that'll come in and do this like, both get good coverage kind of evidence gathering, but also be a little bit intelligent. Like it's not going to help you to get like 10,000 fingerprint samples. You want 10, right?
Right. You want the important ones.
Exactly. So in this, we actually try to bias. If we were just picking sort of arbitrarily, like most of them would be down here at the bottom. In fact, half of them would be below the bottom line. We actually bias towards these longer ones. So even though these requests way up kind of the top here represent, say, only 0.01, 0.05% of the requests, we're going to capture those more frequently than that.
Okay, so tell me more about that biasing, because this sounds like something very different than I've seen other monitoring tools do.
Yeah, it's a little bit tricky to get right, and it's actually kind of feeds into a bit about the way we built it. But really, the idea is that you want to understand as much about the transaction as possible before you decide whether or not it's going to be something that a human is going to want to look at.
Yeah, that makes sense.
And slowness is a great signal to use. Unfortunately, you don't know if a request is slow until it's done.
That's right.
So,
and you need to be capturing the trace as it's happening, not when it's done.
Exactly. So there's a kind of time travel that we have to do to make that happen. And this is pretty different than the way Dapper.
You finally did it.
Yeah, in a pretty narrow case, but we got a kind of time travel. The way Dapper kind of took this approach is that, like, again, there's a bazillion requests. They're all kind of the same. It doesn't matter which. They actually made this decision right when the request started.
Okay.
And we make it at the end, or even it can be seconds or minutes after the request ends, so where there's something else that's interesting that we think is sort of relevant to a human trying to debug what's going on.
Okay, so cool. So now show me what are we seeing when we're capturing these transactions?
Yeah, so let me dig in on one of these things. So this was a request that took about 7 seconds, and we're showing kind of a trace of what you can think of it like a kind of a Gantt chart, or we've got a Chrome debugger or something like that. At the top, what we have is a sort of a summary of what's going on, breaking down each of the services in a different color. And just looking pretty quickly at this, I can tell this purple service here, that's really the bottleneck. That's what's taking, looks like, more than 5 seconds of this request.
Okay.
So if I click into that, I get some more data. I can see this is in an API server. It's doing something called user space mapping. And now if I want to see, why that's happened. Well, I've got a bunch of additional detail. I've got some tags, I've got some logs that are associated with this particular request, and I can see, so this is because we're doing some sort of connection pooling. Pool was exhausted, we stalled.
Yeah, so it's really valuable to have this information sort of all in the same context, right? You've got the trace for the service that's telling you how long things took, but then you're pulling in the log data that's telling you exactly why it took as long as it did.
Yeah.
In this case, it's because, we're out of connections.
Yeah, exactly. So this kind of gets to what we think of as the two kind of fundamental activities in this. One is measurement, understanding when something is happening, probably something gone wrong, and the other is explaining what's happening and being able to get to kind of the root cause of these things.
So one other thing that you may need to do is to understand, all right, so we knew that when we captured this trace here was the problem. how representative is this of everything else that's going on?
Yeah, exactly. Like, is this still happening? Right?
Yeah.
So one of the things, we have this kind of time travel in a sense. What we can do is we can look at all the requests for this particular service that occurred over, say, the last 5 or 10 minutes. And then we can kind of break that down. Here we're showing a histogram, not a time series. So this is trying to sort of plot the population. And you can kind of see there's such a kind of a funny shape here. It's not totally smooth. It looks like there's sort of maybe 2 distinct things that are happening based upon that shape. So what I can do is I can kind of filter, look at some of those. I can compare to what it looked like before. Maybe the shape changed a little bit over the last hour.
That's very useful.
And now I've got a bunch of examples of these kinds of transactions that have occurred recently in the last minute or so. And I can get a quick summary of like what the problems here might be. Again, it looks like this user space mapping thing, still a problem for these slower transactions.
All right, very cool. So this looks great. Obviously, it takes a lot of data and a lot of processing to make all this happen.
Yeah.
So how does LightStep actually work?
Yeah. So we've got kind of logically anyway this what we think of as a hybrid architecture. So certainly part of LightStep is a SaaS tool, but part of it also is an on-prem component. So we call that on-prem the satellites. And the satellites are really gathering data from all kinds of different sources. It could be from your microservices. It could be that we patched in with your monolith, because you probably still have one of those. Everyone still has at least one. And we've even patched in with other logging tools and things like that, and as well as gathering data from clients. And all of that data goes to the satellite. So this is where we're a little bit different than something like Dapper, where even at that point within the application itself, some sampling was already happening. For LightStep, all of this data gets to the satellites. So the satellite's getting this crazy fire hose of data. And they're holding on to it just for a few minutes, basically long enough for us by coordinating through the SaaS side of things to understand whether or not there's anything interesting there.
Okay. So tell me what's happening once the satellites kind of do their magic. They send the data to the cloud.
Yeah.
What's happening there?
Yeah, so a couple of things. One was we're collecting the statistics, so we can do things like show you P99. The other thing that we're doing is sending requests back to the satellites, actually. So it's sort of a bi-directional protocol that we do, because it might not be that something was interesting in itself. It was actually perfectly fine, but it provides important context for understanding why something else was slow. And we sort of, you can think of the satellites as kind of an online stream processing system.
Sure. Okay, that makes sense. All right, so then the next logical question is, the SaaS, the cloud component is built on Google Cloud.
That's right, yeah.
How did you do that?
Yeah, so I kind of think about where we want to put our time from as a kind of engineering organization. Where do we want to use things off the shelf that are meeting our needs, and where do we need to add our own kind of special sauce?
So I see you've got Kubernetes on here.
Yeah.
You've got Cloud SQL. And Spanner as well.
Yeah.
So I'm really interested in all of this. Let's talk about Kubernetes first, right?
Sure.
Obviously, this is something that lots and lots of folks are interested in. Like everyone's building stuff on Kubernetes. Tell me about how did you arrive at kind of building things on Kubernetes?
Yeah, if you kind of go way back to kind of the very beginning of LightStep, we had our monolith in the beginning. We didn't start with anything too fancy. We had a little bash shell script that we used to do deployments. And eventually that shell script became not such a little shell script anymore. I only put the first few lines of it on here. The rest of it's a little bit embarrassing. But we got to a point where I was just, it was getting, there's too many ways to fail, too many ways, I don't want to write tests for this kind of thing, right? And
That's right. Anything that you're using in production should be tested, and then when you're having to write tests for your shell scripts, then you're in a tough place.
Yeah, not the right place. So what I was kind of thinking about at the time is I wanted to kind of leapfrog ahead. I didn't want to skip, I don't want to date myself by saying, where I think shell scripts come from exactly, but I didn't want to skip to 2004 or anything like that. I wanted to skip, right to whatever, 2016, 2017. So for me, that wasn't let's kind of set a lot of this sort of configuration management aside and just go straight to something like Kubernetes.
Okay. So how did you end up deploying Kubernetes in production? Did you end up using one big cluster? Do you have lots of smaller clusters? How did you kind of make those decisions?
Yeah. In several times, maybe over and over, but we started with one. I guess obviously that's where you always start. I think we thought about building out a bunch of them at some point. Where I kind of arrived at is I think it's nice to have two in a lot of ways. As much as we use Container Engine, and Container Engine automates a lot of things and runs the master, and I'm super happy that someone else is monitoring that kind of thing for me. But there is, you still have to understand what's going on. You still, node upgrades are super easy, but someone's still got to do it and click that button. So I didn't really want to be in a state where like every engineer was managing their own Kubernetes cluster. That's too many. On the other hand, I like having a couple so that we can test out, new node versions, things like that in a non-customer facing environment.
Okay, so you basically have like one, we'll call it like test, and then one production cluster kind of thing?
Roughly, yeah. I mean, the test one's used for a lot of things, not just load testing, integration testing. It's used for a bunch of developer things.
Okay.
Other folks at the company want to play with stuff, they can do it there. It lets us keep that thing pretty open as well, because there's no customer data in that, so it's like, if you want to play with it, go ahead.
Okay. So given that your infrastructure is relatively straightforward, how did you end up splitting the team and the responsibilities to do things like, even that one cluster, like you said, still requires some management, right? Someone has to decide to upgrade the nodes versus someone else who says, okay, here's the code that we're pushing. So how did you end up like sort of divvying up those roles?
Yeah, so we have certainly some experts in these kinds of things who who are kind of keeping track of that and are aware of when we need to do upgrades and things like that, and probably handle a lot of that. But I didn't really want to create a team whose job was just to do that. In a sense, like maybe when we're bigger, we get to scale of other companies, we'll have to do that kind of thing. But to me, like I wanted to keep DevOps or SRE to be a super collaborative kind of engagement, and that means that like our SREs actually are sort of embedded in teams and do some small amounts of product development work as part of that. And I think that actually helps them build a lot of empathy for their customers with other engineers at LightStep. Yeah,
that makes sense, right? When you're responsible for supporting this thing, but you've also been the one to figure out what to push to production. You're operating under the same SLOs and air budgets. Yeah, that shared empathy is super important.
Exactly.
Okay, very cool. So now let's talk about the back end.
Yeah.
You got a lot of data coming into the system.
That's right.
Where's it going?
Yeah, that's the hard part, I think. If you don't have persistence, like everything's pretty easy, right? So, I mean, there's some stories in this. I think, back in the day when LightStep was just a demo and just a pilot, like we started just developing from our laptops, right? And so we were running MySQL locally. It's pretty easy, and we put a ton of data in there. Probably some data that shouldn't have been there, but it was a demo, right? So you just move it fast. I think this is a thing that always kind of like, not haunts me, but I think back about, like we've been kind of continuously operating LightStep from those very early pilot days. And
I mean, that's fairly common, right? Startups, you kind of you often come out of something like a hackathon. You've got this thing that you've built overnight, and suddenly you're doing sales calls to customers and running in production.
Part of me, the engineer deep inside, like wants to like make a clean start and start on V2 and things like that. But I just there's no time, and it's probably not the right thing anyway.
It's never the right time to start from scratch.
Yeah. So a lot of the stuff is in MySQL. Definitely some things that shouldn't be. One of those was a bunch of time series data.
Yeah.
Not super high frequency, but like still time series data itself. And when we moved into cloud, we were really starting to overwhelm the cloud SQL servers with just the write rate and keeping up with replication and things like that.
Yeah, and so it's interesting that you bring up time series and write rate, because whenever I talk to customers that have that particular problem in their environment, I always say, hey, Bigtable was built to do just that.
Yeah,
and you've got it on your slide here, so you're kind of doing my pitch for me.
Yeah. We actually took kind of a long path through these. Which may be not totally evident. So we actually moved to Cassandra first. This was actually before Bigtable was a product. So,
wow.
That was sort of where we were first feeling the pain around this. And Cassandra was great in a lot of ways, although I think in retrospect, I never want to sort of underestimate the amount of expertise that's required to run a distributed storage system.
Yeah, that makes sense.
So we actually got into a pretty bad state with Cassandra. So we run a couple of different environments. One of them we call Meta, which is the LightStep environment that monitors the other LightStep environments.
Okay, that sounds important.
Yeah. I mean, for us, it's important to understand. Our customers depend on us to be up and understand their systems. We got to be available. So the Cassandra cluster that we were running as part of the Meta environment got into a state where one of the nodes is corrupted, and we had not done a great job of some of the configuration, and it was basically going to be a significant outage for us to recover that thing. And that was, again, non-customer facing environment, so we could make it work. But
probably not a pattern you want to be in.
Yeah, exactly. I didn't, what was going to stop this from happening in a customer facing environment. So we actually wanted to move pretty quickly to get out of that state and migrate our data elsewhere. So we actually did some evaluation of a Bigtable and a Spanner at that point, and kind of looked at like, what are the costs going to be? What are the sort of overhead in terms of the latency that's going to introduce into our product, and what are the kind of different features that are available in those things.
So I actually want to come back to Spanner, but tell me more about that evaluation.
Yeah, so
how did you do it and what did you see?
We actually used LightStep itself to do some of that evaluation, which is pretty fun. So this is just showing latency for the reads against Cassandra and against Spanner. The big table ones, we ended up reproducing some of this. It actually looked fairly similar to the Cassandra one in a lot of ways, maybe not super surprisingly. But yeah, I think this kind of gets back to what we were talking about before about the difference between P50 and P99 latency. So if you look at the median latency, Cassandra's actually a little bit faster, which sort of expected. It's in the same cluster.
Yeah, it's not surprising.
And so it was, median was about 2 milliseconds.
That's pretty fast.
Yeah, it was great and cool. Spanner a little bit slower, about 6 or 7 milliseconds.
Still pretty fast.
Still pretty fast, totally within bounds for what we needed in terms of our application and the performance we needed. But if you look at those longer tail latencies, actually there's this huge spread, and kind of shown in the graph here, sort of by the distance between the lines on the Cassandra side, that the P99 latency was 2 orders of magnitude bigger.
That's a pretty big distribution.
Yeah, so 1% of them were actually 250 milliseconds.
Okay.
On the Spanner side, incredibly tight. So Spanner just had this really predictable behavior, and to us that was kind of a comforting thing.
Yeah, it's almost, I think, the decision you made, right, it's better to be slightly slower but completely predictably so than a bit faster but much less predictable.
Yeah, and there were some other features around kind of the replication that were available at Spanner at the time anyway that were also pretty attractive to us.
All right, so let's go back a step, because one of the things I'm really interested in is kind of how you're using Spanner, right? This is a conversation that I have with customers pretty frequently that basically think that Spanner is basically the next relational database. And so if I'm in something like Cloud SQL today, then Spanner, once I get to a certain size, Spanner is just sort of the logical next step, right? And they just think of it as it's a big, sort of globally consistent relational database, but the thing they really care about is that it's just it's like a fully managed relational database.
Exactly, yeah.
And then you have different customers with different use cases where what they really care about is that global consistency. Is that's absolutely what they need, and the only way you get that, certainly in GCP, is on Spanner. And I think the only way you get that in the world, quite honestly.
Yeah.
Where did you kind of end up? How did you make your decision to go to Spanner?
It was kind of a mix of those, I think. So part of it was we were being a bit reactive. We had this cluster that could fail at any moment.
You needed to do something.
Yeah, so we needed to do something, and I think Spanner had the flexibility to make that migration pretty easy. I think for all these things, LightStep's going to change a lot. We're going to build some new cool stuff in the future. Google Cloud's going to offer a lot of cool stuff in the future too. We're going to make more migrations. And so to me, the thing that was really attractive about Spanner, I guess part of it was the kind of global replication, and that made us feel good about having the data wherever we needed it. But really putting us in control in terms of when we were going to have to migrate again, and knowing that it was going to scale to whatever we needed.
It's much better to do the migration when you think you're ready rather than when your infrastructure says,
Exactly. So we can plan, this quarter we're going to do feature or we're going to do migration. No, we're going to push the migration off to Q1 and be comfortable knowing that their solution is going to scale to that.
All right, very cool. All right, so we've talked about, actually I did want to ask one more question that I forgot to ask you about on the Kubernetes, and I don't know if you want to get into this now. Can you tell me a little bit about how you're doing multi-tenancy in Kubernetes?
Yeah. It's a mix. So we have some things where we do shared tenancy, where there's relatively low overhead in terms of or maybe not low overhead, but just like low computational cost of what we need to do. And we also have cases where we want some more isolation, and we use a combination of labels and some tainting to make that happen. Yeah.
Awesome. All right, so we're starting to get kind of near the end here. This is a lot of really good stuff here. I think you've learned some really interesting, really important lessons as you kind of first got into the cloud and then kind of made some technology changes and technology migrations. If you were to leave, our audience with just a couple of things that you think they should learn from your experience, what would it be?
Yeah, so I think one of them you kind of are asking about a bit, like what was the kind of cluster architecture that we set up? I really like, for all these kinds of questions, the number 2, because 1's probably not enough. It doesn't give you a chance to test things out.
Sure.
10 or 20 is probably a lot.
It's getting back to what you're talking about, where you don't want every engineer to have to manage their own cluster.
Exactly. But I think, going back, there's some things that I might have thought a little bit harder about, and I would encourage other people to do, and thinking about, how are you going to be able to attribute these infrastructure costs to your customers?
Yeah.
Is that something that is interesting to you? I bet that's going to be interesting to your CFO someday.
Yeah.
Thinking about how you're breaking up billing in terms of, where are you spending money on customer-facing environments and where are you spending money on a load test? And just being able to understand that over time is really important. I think that's influenced some of our decisions around Kubernetes, but also in the storage itself. When do you create a new instance? When do you make a new bucket? Things like that.
Yeah, that makes sense.
The other thing I was thinking about a bit, and something I would like to continue to do better for us even, is just kind of step back and think about the big picture around storage. Like I sort of described in terms of how we kind of got to Spanner, that code, followed this path from, MySQL to Cassandra, eventually to Spanner. And, there's a legacy there in a sense that that code was originally written with a very different set of constraints.
That's right.
And I think, if you're going to be at a point where, you're going to be on one of these hosted storage systems, which I think is a great thing about productivity, really thinking about how the features that are only available in those platforms could actually influence the kinds of features that you build. So some of the more interesting features of Spanner, things around BigQuery, there's a lot of things that you can do that are really cool that you can't do on your laptop.
That's right.
And that I think would be great to think about when you're designing features in that product that you want to build.
Yeah, and obviously the trade-off there then is this concept of lock-in, right? If you're building stuff with specific GCP features, you get a lot of value out of that. But yeah, then you're sort of tied to the platform.
Yeah, and I think that's a trade-off to make. There's the way I think of it is just there's a lot of different features out there, and you take advantage of the best thing. As much as Cassandra doesn't lock you in any way, there's a set of expertise that we would have had to build around that, and that's an investment there that we would have to make if we really wanted to.
Yeah, and then the bigger you get, the more critical that Cassandra system is to your customers. The more you have to invest in making sure that you have folks on staff that can build it, manage it, run it.
So you're going to make that investment one way or the other, I think.
Yeah, okay, cool. All right. Well, thank you so much. Really appreciate it. Please stay tuned for live Q&A. We'll be back in less than a minute. All right, welcome back. Let's go through some of our questions. So first question we have is around machine learning, right? So are you considering using kind of machine learning to improve some of the information that you're providing to your users?
Yeah, this is a question we get a lot, actually. Machine learning and observability, I think, is a really tricky thing.
Yeah.
Being wrong in a way where you've woken up an engineer at 3 o'clock in the morning. Oh, no, it wasn't a problem. Sorry.
That's right.
It's pretty different, and
That's right.
the confidence that an engineer is going to have in that system is going to go down really fast with those kinds of false positives. I think the way that we think about LightStep a lot is kind of a guide. So other places where we can use machine learning to better surface the kinds of facts and sort of evidence that can help you make a decision, but really putting those facts in front of you for you as a human to choose, because in the end, you just have state that the machines don't have in terms of
That's right.
where the releases happened and sort of the organization, how the software's devolved, all those kinds of things.
Yeah, and if you kind of go back to things like SRE principles, right? The idea is that you want to spend all the time up front identifying your SLOs, your SLIs, and then when you're doing things like alerting, it's off something that you've designed very intentionally.
Exactly. Yeah.
Awesome. All right, so we started out talking about microservices. Did you build LightStep on using microservices?
Yeah, not from the beginning. I think we started from a single statically linked Go binary, and that actually we actually still have pieces of that today, which is living on and is sort of a continual challenge and a place where we have to invest in our own infrastructure. But yeah, I don't think I mean, as much as microservices can be great in a lot of ways, if you're one person sitting at your laptop, like, microservices are about scaling.
Yeah.
They're about, dividing up your application in a way that like maps into your organizational structure, right?
Yeah.
They're about fault isolation. If you're running everything on your laptop with you coding it, like none of those things are valuable.
That's right. Yeah.
So
It's something you have to have a lot of foresight when you're first starting out. So if you're literally just one person building on your laptop, you have to think about what is my life if this thing works, what is my life going to be like a year from now?
Yeah.
And you have to think, if you want to kind of go down that route, you have to be very much forward thinking. And it's hard to do that when you're
and there's an investment in doing that, right? Because that slows things down.
Yeah,
right?
all
Now
that
it's
is
like
overhead.
you've got to deploy multiple services when before it was just to push a single binary. So.
All right, cool. One more question I think we have time for. Obviously we've talked a lot about what you're doing on GCP. Are you running LightStep in a multi-cloud way or not?
Yeah, so part of it does run today, like in that we have this kind of hybrid architecture.
Mm-hmm.
So certainly some of our customers run parts of LightStep on other cloud providers.
Sure.
They run it on bare metal in their own data centers. And so in some ways we actually feel kind of, we get the advantages and all of the pain from running both on-prem software and a SaaS solution. But yeah, I think as we move forward, like kind of getting back to what we were saying about lock-in, like I just see these as opportunities. So if there's places where we can, get value by using a solution on a different cloud provider, that's great. Like that's part of what microservices really offers as a way to build applications.
All right, awesome. Hey, thank you so much for being here today.
Yeah.
Really appreciate it.
Yeah, no, it was a pleasure. Thanks.
All right, folks, please stay tuned for the next session, which is going to cover Google Docs tips and tricks to boost your productivity. Thank you very much.